Right now, a violently radioactive storm from dead, exploding stars is crashing into an invisible wall billions of miles from Earth. If that wall drops, the biosphere of this planet is instantly sterilized. For decades, we comforted ourselves with the belief that this boundary was a solid, permanent fortress. We were wrong. When we finally built instruments capable of touching the absolute edge of our solar system, the data came back completely broken. Our shield isn't stable. It is deformed. It is actively leaking alien matter. And the deeper astronomers look, the worse it gets. Massive ribbons of unexplained energy spanning the entire sky. Invisible gravitational ghosts lurking in the dark. And the terrifying discovery that a cosmic shockwave triggered 70,000 years ago is currently creeping toward Earth right now. Something strange is happening at the boundary of our home, and it never stops getting worse. But to understand exactly how much danger we are actually in, and whether this cosmic threat is about to break through, we need to look at the cold, hard data. The danger becomes clear only when you look at what's waiting outside. The rest of the galaxy is a violently radioactive place, completely saturated with galactic cosmic rays. Think of them as invisible shrapnel, high-energy particles, mostly protons, blasted out by exploding supernovas thousands of light years away and accelerated to almost the speed of light. This cosmic radiation comes at us from every direction, all the time. It's like a deadly storm that never clears. You can't see it or feel it, but right now, some of these particles are passing straight through your roof, your skull, and your DNA without asking permission. Why aren't we all dying from radiation sickness? Because of the heliosphere. This giant magnetic bubble created by our sun acts as a shield, blocking about 70% of those deadly cosmic rays. Only the remaining 30% manages to get through to Earth. That 70% margin is the only thing standing between the safe, hospitable world we know and a heavily irradiated planet where complex life would struggle to survive. But here's the part that should really bother you. That 70% shield is not a permanent guarantee. The number fluctuates. Its strength depends on how hard the sun is blowing its solar wind out, and how hard interstellar space is pushing back in. We tend to think of our solar system as a stable place. The sun has been burning consistently for billions of years, right? But that ignores the other half of the equation. As our entire solar system orbits the center of the Milky Way, we constantly fly through different regions of space. Sometimes the interstellar clouds we pass through are thin. Sometimes they are thick and dense. When the galaxy pushes in harder, our protective bubble shrinks. And if the bubble shrinks, that 70% protection drops. We are only just beginning to understand how fragile this balance is. In fact, until 1958, we didn't even know this shield existed. An astrophysicist named Eugene Parker was the first to predict the solar wind, the energy blowing out from the sun that creates our bubble. And how did the scientific community react? 2 peer reviewers rejected his paper, calling his math physically impossible. 4 years later, a spacecraft flew up there and proved every single number right. The man who discovered the very mechanism keeping us alive had to fight just to be taken seriously. This is a pattern that keeps repeating in space science. We were wrong about whether the solar wind even existed. Decades later, we were wrong about the shape of the heliosphere's edge when our Voyager probes finally reached it. This begs a terrifying question. What are we wrong about right now? That 70% is the most important number most people have never heard of. For decades, we have been blindly treating it as a constant, assuming it will always stay the same. But the universe doesn't make promises, and we might just be one scientific instrument away from finding out how vulnerable we really are. We like to think that our 70% shield has always been there, steady and reliable, but it hasn't. The shield has dropped before, and we don't have to guess about this because the Earth itself kept the receipts. Here is how planetary record-keeping works. When those violent galactic cosmic rays we just talked about manage to punch through the heliosphere and hit our upper atmosphere, they smash into oxygen and nitrogen. This microscopic car crash creates a very specific radioactive fingerprint, an isotope called beryllium-10. It snows down from the sky, settles deep into the ocean floor, and gets locked in the sediment. Imagine it as a giant planetary Geiger counter. Nobody built it, nobody turned it on, but it has been quietly running for hundreds of millions of years, recording exactly how much radiation was leaking through our solar shield. And when scientists pull up deep sea core samples to read that logbook, they notice something alarming. The record isn't flat. The amount of radiation spikes wildly throughout geological history. To understand these spikes, remember that Earth has its own internal secondary shield, our magnetic field, or magnetosphere. Sometimes Earth's magnetic field naturally flips or weakens, which lets more cosmic rays in. Geologists can easily spot those local glitches. But what happens when they find massive radiation spikes in the sediment that do not match Earth's magnetic changes? Those spikes point directly out into deep space. They tell us that the sun's giant bubble, the heliosphere, physically compressed or weakened. The outer shield failed, and a flood of radiation left a chemical signature at the bottom of our oceans. It is tempting to write this off as ancient history. Events that happened millions of years ago have no bearing on us today, right? But here is where that argument collapses. Our solar system isn't just floating still in the void. We are a spaceship, hurtling through the Milky Way at an insane 26 kilometers per second. At that speed, we cover the distance from the Earth to the Moon in just over 2.5 hours. We are dragging all 8 planets right through the interstellar medium, and the density of space changes depending on where we are flying. Right now, humanity happens to be cruising through a relatively warm, thin, and safe pocket of gas called the local interstellar cloud. We flew into it roughly 60,000 to 150,000 years ago, right around the time modern humans were migrating out of Africa. But we are running out of safe space. We are rapidly approaching the far edge of this cloud. Waiting on the other side of that edge is something called the G cloud. It is denser. It has a different, stronger magnetic field, and it is going to push back against our bubble much harder than what we are used to. Priscilla Frisch, an astrophysicist at the University of Chicago, calculated exactly what happens when we hit that wall. The incoming pressure forces the heliosphere to compress inward. Our protective buffer physically shrinks, and the deadly radiation getting through goes up. The terrifying part? We don't know exactly when we will cross that border. The transition might be centuries away, or it might already be underway right now. We have no warning system, no sensor sitting out at the edge of the solar system to ring a bell. Those radiation spikes buried in the ocean floor are not ancient curiosities. They are a warning. And we are flying blind toward a region of space that could trigger the next one. But flying blind into a denser cloud is only half the nightmare. Because our shield isn't just preparing to take a hit. It is visibly deformed. And the crazy part? We only found out completely by accident. Let me take you back to the early 2000s. We had 2 ancient spacecraft, Voyager 1 and Voyager 2, slowly making their way out of the solar system. In 2004, Voyager 1 finally crossed something called the termination shock. This is the inner border of our heliosphere, the invisible line where the solar wind suddenly slams on the brakes. Picture this. You know when you turn your kitchen faucet on full blast and the water hits the flat bottom of the sink? It spreads out super fast, but then suddenly slows down, piling up into a thick, visible ring of water. The termination shock is exactly like that water ring, except it wraps around our entire solar system. Voyager 1 hit that ring at roughly 14 billion kilometers from the sun. 3 years later, Voyager 2 crossed the exact same boundary, but heading in a completely different direction. It hit the wall at only 12.5 billion kilometers out. Think about that for a second. It's the exact same structure, measured in 2 different directions, but there is a 1.5 billion kilometer gap between them. That means there is a massive dent in our shield, a dent larger than the entire distance from the Sun to Saturn. Nobody saw that coming. Why should you care about a dent in deep space? Because that dent tells us that our giant protective bubble is literally being crushed on one side. And it just so happens to be the exact side facing the direction we are traveling through the galaxy. Think of it like driving a car where the front windshield is dangerously thin. Thinner armor means less shielding. It means more of those deadly cosmic rays are pouring into the inner solar system from that one specific patch of the sky. And worse, that weak side is pointing exactly at the denser space we are currently hurtling toward. It's only going to compress further. At first glance, 2 random measurements aren't enough to draw massive conclusions. But these aren't just 2 random samples. These are the only 2 times in the entire history of our species that we have physically touched the edge of our solar system. And both times, the data completely broke every single model we had. If 2 out of 2 data points say our math is wrong, then our math is wrong. We don't need a third probe to tell us that. This leaves us with a terrifying set of questions. What is happening at the front edge of our bubble right now? Not in 2004, but tonight? How much worse does the deformation get as we plunge into that new interstellar cloud and external pressure spikes? We simply have no instruments out there left to answer us. And as if the external pressure wasn't enough, we have to consider the gravitational mechanics of the galaxy itself. As the galactic tide pulls us in different directions, some theories suggest this stress doesn't just affect our outer shield, it reaches all the way to Earth. If those shifting gravitational forces create enough internal tension deep inside Earth's core, we aren't just looking at a radiation problem. We could be looking at the splitting of tectonic plates, massive geological upheavals, and the eventual destruction of our coastal cities. Knowing our armor is dented is one thing, actually touching the outer wall is another. We still had to hit the Heliopause, the absolute outermost boundary, the actual physical wall separating the safety of our solar system from the deep, dark galaxy. On August 25th, 2012, Voyager 1 finally reached it. At 121 astronomical units from the Sun, that is over 18 billion kilometers out in the pitch black, our little probe touched the edge. For 50 years, astrophysicists had been building up to this exact moment. They had their complex math, their theories, and a very specific checklist of 3 things that were supposed to happen when a spacecraft pierced that final wall. And guess what? All 3 predictions completely failed. First, the magnetic field was supposed to clearly change direction. Inside the bubble, it's shaped by the Sun. Outside, it should be shaped by the galaxy. But when Voyager crossed, the magnetic field didn't budge. Second, the interstellar plasma hitting the probe was supposed to be freezing cold compared to the solar wind. Instead, it was shockingly hot. Third, the pressure between the inside and outside was supposed to balance perfectly according to our models. It didn't balance at all. The smartest minds at NASA's Jet Propulsion Laboratory were so utterly confused that they spent 12 agonizing months debating whether Voyager 1 had actually crossed the boundary or not. The data coming back to Earth looked absolutely nothing like what the textbook said it should. In the end, they only confirmed the crossing because of one terrifying measurement that actually did what it was supposed to. The cosmic ray count suddenly spiked. Voyager had officially stepped outside our protective bubble and straight into the radioactive firing squad of interstellar space. But every other piece of data contradicted half a century of careful, peer-reviewed work. The boundary was definitely there, it was just nothing like what anyone had described. At first glance, this just looks like normal science. You make a prediction, you measure, you correct. But these were not minor tweaks. We weren't adjusting a number in the 3rd decimal place. We were looking at fundamental structural errors about the basic physics of the barrier keeping our planet alive. This wasn't like fine-tuning a map of a city. This was like looking at a map of the world and realizing you drew an entire continent on the wrong side of the ocean. So the agonizing question became, was this just a weird, local glitch? Did Voyager 1 just happen to punch through a messy, turbulent patch of the shield? Or was our entire understanding of the solar system completely and utterly wrong? There was only one way to find out. We had a second spacecraft, Voyager 2, speeding toward a completely different section of the edge. All we could do was hold our breath and wait for it to hit the wall. We placed all our hopes on Voyager 2 to give us a normal reading. We assumed it would hit a calm, predictable boundary. It didn't. On November 5th, 2018, Voyager 2 crossed the Heliopause, and the data it sent back was just as baffling, but in entirely new ways. For starters, the plasma temperature on the outside of the wall was 10 times higher than our models calculated. Let me repeat that. Not 10% higher. 10 times. The magnetic field data completely disagreed with what Voyager 1 found 6 years earlier. The pressure coming from the south didn't match the pressure from the north. We had two spacecraft crossing the exact same boundary in two different places, and they gave us two completely incompatible physical descriptions of reality. Honestly, this should have been front-page news worldwide, because what it tells us is that our protective shield is not a smooth, uniform membrane. It's not an eggshell, it is a turbulent, boiling, asymmetrical mess. Its physics physically shift depending on the direction you look, the time you measure it, and local space weather conditions we haven't even begun to map out. Desperate to figure out what was going on, scientists tried a different approach. Since the Voyagers were just two tiny pinpricks on a massive balloon, they tried to look at the big picture from the inside. We had the Cassini spacecraft orbiting Saturn and the IBEX satellite orbiting Earth. Both were equipped with detectors to catch energetic neutral atoms. Basically, they were catching particles bouncing back from the outer edge to create a distant map of the boundary. But instead of clarifying things, it made the nightmare worse. Cassini looked at a specific patch of the Heliopause from Saturn. IBEX looked at that exact same patch from Earth, and their maps didn't match. Two multi-million-dollar instruments, staring at the exact same wall, returning completely incompatible pictures. Every single time we touch this boundary, and every single time we look at it, it changes. Every measurement contradicts every other measurement. And in science, when every piece of the puzzle looks like it belongs to a completely different box, it means the picture you drew on the whiteboard is fundamentally wrong. Whatever the edge of our solar system actually is, we got it wrong. Structurally, physically wrong. And as if that wasn't terrifying enough, the overall shape of the giant bubble keeping us alive, well, that turned out to be the very next thing we were completely wrong about. This brings us to the most unsettling question. What does this deformed, boiling bubble actually look like from the outside? For decades, the picture we drew on the whiteboard was simple and intuitive. We assumed that as the sun moves through interstellar space, the solar wind gets pushed back in the front and stretches out long in the back. Every textbook, every sci-fi illustration showed the exact same thing. It looked like a comet, a blunt nose at the front and a long flowing tail at the back. It made sense, right? Just like a boat leaving a wake as it moves through water. But in 2015, an astrophysicist named Mehrav Ofer at Boston University took a hard look at the magnetic field data from the Voyager probes, and she published a model that absolutely destroyed that classic picture. According to her analysis, the sun's magnetic field creates tension that pinches the bubble. There is no long flowing tail. Instead, the back of our heliosphere splits into two large, symmetric lobes. Suddenly our solar system didn't look like a comet anymore. It looked more like a giant, cosmic croissant. But wait, it gets messier. In 2020, another revised model came out, pushing the shape closer to a deflated beach ball, meaning no tail and no lobes at all. Then, a third research group ran their own data and produced an entirely different geometry. So here we are, 3 teams, 3 completely incompatible shapes, and 0 consensus. It determines exactly where our armor is thick and where it is terrifyingly thin. If the heliosphere has a long tail, then our backside is relatively shielded. But if it's shaped like a croissant with two lobes, that means there are massive gaps between those lobes, open channels where deadly cosmic rays can easily pour in. And if it's just a deflated sphere, then the front edge taking all the pressure becomes incredibly vulnerable. Think about how absurd this is. We have been living inside this structure for 4.5 billion years, and we are still arguing about whether our home is perfectly round, has a tail, or has wings. But the terrifying truth is, the outer edges of our solar system are so dark and so unmapped that the shape of our shield might not even be the craziest thing hiding out there in the dark. For years, astronomers have noticed bizarre orbital anomalies in the deep outer solar system, icy objects moving on strange paths that no known planet can explain. For a while, people thought it must be a hidden Planet 9. But in 2020, a paper published in Physical Review Letters proposed something much darker. They suggested that the gravitational ghost pulling on those distant objects isn't a planet at all. It might be a primordial black hole. Imagine an object with the mass of 5 Earths, crushed down to the size of a grapefruit. If it actually exists out there in the outer edges of our system, it is absolutely invisible to every telescope we have. It's just sitting there in our cosmic backyard. A silent, unseeable ghost, reminding us that we really have no idea what is sharing our home with us. While the Voyagers probed the physical edge, the IBEX satellite was orbiting Earth, trying to map the boundary from afar. But I haven't told you the craziest part of its story. Back in 2008, when NASA first launched it and turned it on, it had one simple job: look out into the dark and draw a map of our shield. But within the first few months, IBEX sent back an image that literally made scientists drop their coffee. Stretching across the entire sky, taking up a massive band about 20 degrees wide, was a giant, glowing ribbon of energy. It was made entirely of those energetic neutral atoms flying inward from the boundary. This wasn't some subtle, blurry smudge in the data. This was a glowing, colossal stripe painted from one horizon to the other, as obvious and undeniable as a scar across a face. And absolutely no one saw it coming. None of our supercomputers, none of our theories, none of our models had predicted it. David McComas, the lead scientist on the mission, called it the most unexpected discovery in the history of space research. They eventually realized the ribbon somehow aligned with the magnetic field of the galaxy outside, but how it was being created? Total mystery. Scientists scrambled to explain it, throwing out complex ideas like secondary charge exchange or magnetic field draping. It sounds like fancy science talk, but the truth is, it was just guesswork. Here we are, almost 2 decades later, and they are still arguing about what this giant ribbon actually is. Stripping away the scientific jargon, the implications are terrifying. We built a highly advanced camera, pointed it at the sky to check on the invisible shield keeping us alive. And the very first thing we found was a massive structural feature spanning the entire solar system that we had no idea was there. And the ribbon wasn't even the only surprise. IBEX also picked up a weird background hum of energy coming from completely random directions, where the model said there should be absolute silence. It forces us to ask a deeply uncomfortable question. If the people responsible for understanding our survival can't even explain the biggest, brightest feature right on our doorstep, how can we trust the models that say we are safe? And if we found a massive ribbon just by accidentally pointing a camera at the sky, what else is hiding out there in the dark simply because we haven't built the right instrument to see it? With all these broken models and giant, unexplained ribbons, every single mystery at the edge of our solar system always leads us back to one terrifying question. Is our shield actually holding? And if it is, how much protection are we really getting? Now, thanks to those Voyager probes we talked about, we know that the shield is physically working right now. Inside the bubble, radiation levels are relatively safe, but the moment you step outside, you take the full, unshielded blast of the galaxy. The problem is, our armor is clearly warped. That giant ribbon in the sky proves the heliosphere is interacting with deep space in ways we don't understand, which means our shield might be incredibly thin in places we think are safe. But it gets worse. In 2016, a team led by Anton Wallner at the Australian National University found something that goes way beyond a simple math error in our models. They found proof that our shield can be completely breached. Remember those deep-sea sediment cores we talked about earlier? The ones acting like Earth's planetary logbook? Well, when scientists looked closely at that mud, they didn't just find radiation spikes. They found an isotope called iron-60. Here is why that should send a chill down your spine. Iron-60 does not naturally form anywhere in our solar system. The absolute only place in the universe it can be created is inside the fiery core of a massive, exploding star. Any iron-60 found on Earth is alien shrapnel, the exhumed, radioactive ashes of a dead star. It physically traveled here from a supernova in deep space, and the ocean floor logbook showed two massive, undeniable spikes of this alien ash. One from roughly 2 to 3 million years ago, and another from 6 to 7 million years ago. And just to prove this wasn't some local Earth glitch, we checked the soil samples brought back by Apollo astronauts. The exact same isotope, from the exact same time periods, was sitting quietly in the dust on the moon. Think about what that means. A massive star exploded light years away, and the blast was so powerful that physical debris crashed straight through our solar system's defenses, raining down on both the Earth and the Moon, twice within the last 7 million years. Whatever shielding we had at the time completely failed to keep it out. It is tempting to dismiss supernovas as incredibly rare events, but their frequency is not the point. The delivery is the point. The shield let it through. It has collapsed before. We tend to think of our current peaceful solar system as the norm. But the truth is, our quiet time is the anomaly. The universe is a violently radioactive place. Our biosphere is so incredibly fragile that if the galaxy ever returned to its factory settings, we would be instantly incinerated. If our solar shield is leaking and alien supernova shrapnel is physically hitting the ground, we have to ask a much bigger, much more dangerous question. Did all this cosmic radiation actually do anything to our world other than leaving a chemical footprint in the mud? In the late 90s, an astrophysicist proposed an idea that connected the dots in a way that blew people's minds. He suggested that cosmic rays don't just pass through our bodies, they physically change our weather. Here is how his theory works. When those high-energy cosmic rays punch through the heliosphere and slam into our lower atmosphere, they ionize the air. They electrically charge the molecules. Suddenly these charged particles act like tiny magnets. Water vapor in the air gets attracted to them, clings to them, and forms water droplets. In science, we call them cloud seeds. The math is brutally simple. More cosmic rays leaking through our shield means more cloud seeds. More seeds mean more clouds covering the Earth. More clouds mean more sunlight gets reflected right back into space, which causes the entire surface of our planet to cool down. Think about the sheer scale of what Svensmark was saying. An invisible, magnetic bubble sitting 18 billion kilometers away could literally be acting as Earth's global thermostat. At first, the broader climate community pushed back hard. They argued the effect of space radiation on our clouds had to be way too small to matter. But then, in 2011, the scientists at CERN, the massive particle physics lab in Europe, decided to settle the debate. They built a high-tech chamber, filled it with artificial Earth gases, and fired a high-energy particle beam straight into it to perfectly simulate galactic cosmic rays. And guess what? It worked. The particle beam created cloud seeds at the exact rates Svensmark had calculated. The first fundamental link in the chain wasn't just a theory anymore, it was experimentally proven in a lab. Whether this cosmic thermostat operates on a global scale is still fiercely debated. But if it does, it reshapes everything we thought we knew about the history of our planet. It means those wild beryllium-10 radiation spikes we found buried in the ocean floor weren't just radiation events. They were massive climate events. Every time our shield weakened, the Earth got colder. And this brings us to a terrifying realization. Remember that dense, high-pressure G cloud we are currently flying toward? The one that is going to crush our protective bubble? If our shield shrinks, the radiation won't just give us a slightly higher risk of cancer. It will show up in our weather patterns. It could trigger global temperature shifts, devastate crop yields, and radically change global ice coverage. Has anyone actually cross-referenced those ancient radiation spikes with the unexplained ice ages in Earth's history? What exactly happened to our cloud coverage during the 2019 to 2020 solar minimum when cosmic ray levels hit a modern record high? And most importantly, if this cosmic thermostat is even partially real, what exactly is going to happen to us when we finally hit that G cloud? If this invisible cosmic thermostat is real, we aren't just talking about a few bad winters. The connection goes infinitely deeper. We might be looking at the trigger for massive ice ages, and beyond that, the total elimination of life on Earth. To understand how, you have to look at how we actually move through space. Our solar system isn't just flying in a straight, flat line. Think of the Milky Way galaxy like a giant spinning record. As we orbit the center, we ride a cosmic carousel, slowly bobbing up and down, crossing through the dense, dusty middle of the galactic plane every 30 to 35 million years. And the middle of that plane is a dangerous neighborhood. It is packed with denser gas, more dust, and way more exploding stars firing cosmic rays in every direction. In 1997, scientists noticed something terrifying. The timing of Earth's major ice ages perfectly matches our solar system's bobbing motion through the galaxy. A few years later, astrophysicists Mikhail Medvedev and Adrian Melott took it a step further. They argued that every time we plunge into that dense galactic plane, our shield gets overwhelmed. The cosmic ray flux spikes. The Svensmark cloud mechanism goes into absolute overdrive. The sky goes dark with clouds, and the planet freezes over. The math checks out. Earth's deep freezes cluster in patterns that perfectly match where we were in the galaxy. But the horror story doesn't stop at ice. Over the last 500 million years, life on Earth has been nearly wiped out 5 different times. The Ordovician extinction 443 million years ago. The Devonian. The Permian, which was so brutally violent that it killed off 96% of all marine species on the planet. Then the Triassic, and finally the Cretaceous, which took out the dinosaurs. When Professor Medvedev looked closely at these events, he found a chilling correlation. Some of our planet's most devastating mass extinctions line up perfectly with periods when our solar system was passing through specific, highly radioactive regions of the galaxy. Now, the skeptics out there might say, come on, correlation does not equal causation. And technically, sure, you would be right. But let me ask you, how many correlations do we need to find before we stop calling them coincidences? How many mass extinctions need to line up with the exact same cosmic pattern before we finally admit the terrifying truth? The galaxy might literally be hitting the reset button, culling life on Earth at regular intervals. And if the radiation isn't enough to kill us, there is one last, horrifying loophole in our defense system. Our heliosphere is a magnetic shield. It only deflects things that have an electrical charge. That means any matter flying through space that carries no charge, like interstellar dust, passes right through our walls as if they aren't even there. If those uncharged particles carry complex, alien organics, like cosmic viruses or prions, they could silently drift down into our atmosphere. They could settle onto the surface of our world, introducing biological nightmares that our immune systems were absolutely never designed to fight. But the most terrifying loophole in our magnetic shield isn't about radiation. The boundary of our solar system isn't just leaking energy, it is physically leaking alien matter, and we can actually measure the flow. When that IBEX satellite was mapping the sky, it didn't just find that giant glowing ribbon, it also detected actual, physical atoms of interstellar helium and hydrogen floating deep inside our solar system. I am not talking about out at the edge, I mean right here, roughly at Earth's distance from the Sun. Because these atoms carry absolutely zero electrical charge, our heliosphere's magnetic field can't even touch them. They just slip right through the walls. They are constantly arriving from the direction of the Scorpius constellation at a blistering speed of 26 kilometers per second. There is a literal interstellar wind blowing right through our planet, continuously, at this very moment. This exposes the darkest secret of our planetary armor. That 70% protection rate we keep talking about, the only thing keeping our radiation environment survivable. That only applies to charged cosmic rays. But for neutral gas, neutral dust, and neutral solid objects, our heliosphere is 100% transparent. The shield has a massive blind spot. A single atom of alien helium drifting by at 26 kilometers per second sounds perfectly harmless. And on its own, it is. But the atom itself isn't the threat. The principle is, if neutral gas can waltz right through our defenses, what else gets through? Interstellar dust gets through. And if dust gets through, larger things get through. In fact, we already know for an absolute fact that massive, solid objects from deep interstellar space have penetrated the inner solar system at least 3 times in recent years. You might have even heard of them on the news. Bizarre, fast-moving alien rocks like Oumuamua and the comet Borisov. They weren't born in our solar system. They came from the deep dark, punched right through the Heliopause, and flew right past Earth. And our giant protective shield couldn't do a single thing to slow them down. When that first alien visitor, Oumuamua, appeared in our skies, it immediately broke everything we thought we knew about orbital physics. It showed up in October 2017. The Pan-STARRS telescope, sitting near the summit of a volcano in Hawaii, spotted a tiny dot moving across the sky. Instantly, astronomers knew something was wrong. Its trajectory was impossible for anything born inside our solar system. It was moving so fast and coming from such a steep angle that the sun's gravity couldn't capture it. It was a true interstellar drifter, arriving from the void and heading right back out into it. And then there was the shape. It was estimated to be roughly 400 meters long, but incredibly thin, like a giant cigar or a cosmic pancake. Absolutely no known asteroid or comet in our entire solar system looks like that. But the shape wasn't even the weirdest part. The real problem was its acceleration. As Oumuamua swung past the sun and started heading back out into deep space, it sped up. It accelerated slightly faster than the laws of gravity alone could explain. Usually this kind of acceleration is seen in comets. As they get close to the sun, their ice vaporizes, creating a glowing tail that acts like a natural rocket thruster. But here is the catch. Oumuamua had no tail. Telescopes looked closely and found zero evidence of gas or dust around it. Something was physically pushing this object, and we had absolutely no idea what it was. Scientists scrambled for answers. Some proposed it was a shard of nitrogen ice chipped off a Pluto-like planet in another star system, which would make its exhaust invisible to our senses. Others suggested it was a hydrogen iceberg. Avi Loeb, a top astrophysicist at Harvard, famously argued that its shape and weird acceleration perfectly matched a solar sail, meaning it wasn't a natural rock at all, but a piece of alien technology. The debate is still raging today. We will never know for sure because the object is gone. It passed through our neighborhood and disappeared into the dark. But Oumuamua demonstrated something far more terrifying than the possibility of alien tech. It proved that our planetary defense system is practically useless against interstellar threats. We spend all our time tracking local asteroids, assuming we will have years or decades to prepare if one heads toward Earth. But Oumuamua proved that a massive, solid object can fly in from deep space at mind-bending speeds, and we won't even see it until it is already passing us by. We didn't spot Oumuamua until it was already on its way out. If its trajectory had been angled just a few degrees differently, if it had been on a direct collision course with Earth, we wouldn't have even seen the flash. It was the cosmic equivalent of a sniper bullet flying through our living room. And we only saw the broken glass after the shooter was gone. You would think that after Oumuamua, the smartest space agencies in the world would be on high alert, watching the skies with their billion-dollar equipment for the next alien visitor. But the second interstellar object wasn't found by NASA. It was found by a guy who built his own telescope in his backyard. On August 30th, 2019, Gennady Borisov, an amateur astronomer in Crimea, was looking through a telescope he had painstakingly assembled himself, and he spotted a faint smudge moving way too fast to be bound by our sun's gravity. It was the first confirmed interstellar comet in human history. Unlike Oumuamua, this one actually looked normal. It had a glowing head and a dusty tail. For 75 years, ever since a Harvard scientist named Fred Whipple proposed it, we have thought of comets as dirty snowballs, loose chunks of ice and dust. Borisov's comet proved that alien star systems make dirty snowballs too. But when scientists analyzed the light shining through it, they realized something was deeply wrong. The chemistry was totally alien. Its carbon monoxide levels were up to 9 times higher than any comet we have ever seen in our solar system. The chemical recipe alone proved it was born in a freezing, distant, unknown corner of the galaxy. Now, this discovery of alien ice flying through our neighborhood brings up a massive, deeply uncomfortable question about our own planet. For decades, we assumed that Earth got its oceans from local comets crashing into our planet billions of years ago. But in 2014, the European Space Agency sent the Rosetta spacecraft to land on one of our own local comets, 67P. They tested the ice to see if it matched Earth's water. They measured something called the deuterium to hydrogen ratio, basically the chemical fingerprint of the water. The result was a shock. The water on the comet didn't match the water in our oceans. In fact, it was 3 times different. That single measurement proved that Earth's oceans did not come from the standard comets in our solar system. So, put these pieces together. A guy with a homemade telescope found an alien comet zooming right through our backyard. The chemistry of the ice out there doesn't match the ice in here. And the water filling our oceans, the very water inside your own body right now, came from a source we still haven't identified. It forces us to look at that giant, supposedly protective boundary at the edge of our solar system in a terrifying new light. It isn't just leaking radiation. It isn't just letting rocks fly by. The boundary isn't keeping the outside separated from the inside at all. And it's entirely possible that the building blocks of everything we are slipped right through it. Oumuamua and the alien comet could have been dismissed as rare, once-in-a-lifetime flukes. But the third object erased that comforting lie forever. Around July 2025, the Atlas telescope system in Chile picked up an object we now call 3I/Atlas. It was tearing through our solar system at a blistering 60 kilometers per second. To give you an idea of how insane that is, it was moving so absurdly fast and at such an extreme angle that it didn't just escape the sun's gravity, it practically ignored it. That makes 3 confirmed alien objects plunging through our system in just 8 years, 2017, 2019, and 2025. The gap between these visits isn't shrinking because interstellar traffic is suddenly getting worse. It is shrinking because our telescopes are finally getting good enough to see them. Do the math. If we manage to spot 3 of these things using our current, limited technology, the actual number of invisible objects flying through our neighborhood right now is staggeringly high. These interstellar rocks aren't rare tourists. They are constant, heavy traffic. And our giant magnetic bubble, the Heliosphere, does absolutely nothing to filter them or slow them down. They enter and exit, as if our walls don't even exist. Think about how this shatters our illusion of safety. Back in 1705, a brilliant astronomer named Edmund Halley proved that comets run on predictable schedules. He showed that the solar system is like a giant clockwork machine. We know where things are and we know when they are coming back. But these new objects, they don't follow our rules. Nobody calculated their arrival because nobody even knew they existed until they were already inside the house. And here is the part that makes this deeply personal. Space rocks don't just fly by cleanly. As they heat up, they shed millions of tons of debris. They leave a massive, invisible wake of alien dust behind them. Because there is a constant highway of these objects moving through our system, that alien dust is continuously drifting inward. It eventually hits Earth's atmosphere, drifting down from the sky, carrying unmapped isotopes and complex, unidentified organics from dead star systems. Every single day, a tiny fraction of that deep space debris settles onto our oceans, our streets, and our fields. You don't need to fly into a radioactive void to touch deep space. The shield is so completely broken that you just have to take a breath. But here is the truly staggering part. Up until now, everything we have talked about, the heliosphere, the deformed magnetic shield, the cosmic rays, and this alien dust you are breathing, has only been about the inner courtyard of our solar system. The tiny, brightly lit zone controlled by the sun's wind. But the solar system doesn't end at the boundary of that bubble. It extends vastly, terrifyingly further. It stretches out into a region so unfathomably huge that it reaches a fifth of the way to the next closest star. And the craziest part? Absolutely no one has ever seen it. Back in 1950, a Dutch astronomer named Jan Oort was looking at the paths of 19 long-period comets, trying to figure out where the hell they were coming from. He mapped out the absolute farthest points of their orbits, expecting to find that they came from a flat disk, like the asteroid belt. Instead, the math showed something completely different. The comets weren't flying in from a flat line, they were plunging in from every conceivable direction. Top, bottom, left, right. The only geometry that could possibly throw rocks at us from every direction at once is a giant, hollow sphere. And the distance was staggering. Oort calculated that this spherical reservoir sits roughly 50,000 astronomical units away. Consider the scale. Neptune is 30 units away. The edge of our magnetic shield is 120 units away. The nearest star is 268,000 units away. Sitting right out there in the freezing dark, just a fraction of the way to the next star system, is a hollow shell containing roughly 100 billion frozen, city-sized comets. We call it the Oort Cloud, and nobody has ever directly seen it. We only know it exists the same way we know dark matter exists, by watching what it does to the things around it. And what it does is terrifying. Oort realized that these comets are constantly arriving as dynamically new objects, meaning they're falling toward the sun for the very first time. That proves this massive reservoir isn't just a static, sleeping graveyard. Something out there in the dark is constantly stirring the pot. According to our best supercomputer simulations, like the famous NICE model, our solar system was born in absolute gravitational chaos. The giant planets threw trillions of icy rocks out into the dark to form this cloud. And now, billions of years later, that massive swarm of frozen shrapnel is still up there, highly unstable. Every time a rogue star or a dense galactic cloud drifts a little too close to our system, its gravity shakes the tree. And when the tree shakes, fresh, city-sized chunks of ice drop out of the dark and fall straight inward, toward us. Of course, when scientists first suggested that this giant, invisible Death Star of ice existed, they were completely ignored. Jan Oort wasn't even the first to figure it out. In 1932, Ernst Üppig mathematically proved it. Ignored. In 1943, Kenneth Edgeworth proposed a similar belt of ice just beyond Neptune. Ignored. In 1951, Gerard Kuiper proposed the exact same thing, got everyone's attention, and ended up getting his name on it instead of Edgeworth. It is a hilarious, frustrating pattern in astrophysics. Someone proposes a brilliant, correct idea about the outer solar system, the scientific establishment laughs at them, and then decades later, somebody finally builds a telescope powerful enough to prove them right. The Kuiper Belt was finally confirmed in 1992, nearly 50 years after Edgeworth proposed it, when two astronomers found the first object using a massive telescope in Hawaii. But the Oort Cloud? We have been waiting over 70 years, and it is still completely unconfirmed by direct observation. Scientists are 100% mathematically certain it is there, but no telescope ever built has been able to snap a picture of a single Oort Cloud object. Why? Because of a curse called triple invisibility. First, the sunlight out at 50,000 astronomical units is 2.5 billion times fainter than what you see on Earth. It is virtually pitch black. Second, the objects themselves are practically coated in cosmic soot. They reflect almost zero light, making them darker than a lump of charcoal. And third, they are so incredibly cold that the faint heat they do emit glows in a very specific infrared wavelength. A wavelength that Earth's atmosphere naturally absorbs and blocks from our telescopes. You could have an iceberg the size of Manhattan sitting out there right now, and it is completely beyond the detection threshold of any instrument humanity has ever built. But there is one more detail about the Oort Cloud that will keep you up at night. Despite holding 100 billion objects, the cloud is staggeringly, unthinkably empty. The average distance between two neighboring comets out there is roughly 1.2 billion kilometers. That is the distance from the Earth to Saturn. Imagine it. 1 trillion frozen bodies, each one sitting alone in its own massive private void, visible to nothing, touched by nothing, drifting in absolute freezing silence since the dawn of the solar system. We mathematically proved the existence of the single largest physical structure in our entire solar system, without ever laying eyes on a single piece of it. But the Oort Cloud is just the outer wrapper. Tucked inside of it, sitting slightly closer to the sun, is something arguably even scarier. Back in 1981, an astronomer named Jack Hills proposed that the giant outer sphere was just the wrapper. Inside of it, he argued, sits a massively dense, flattened inner ring of ice, spanning between 2,000 and 20,000 astronomical units. Physicists call it the Hills Cloud. If the math is right, this inner ring is an absolute monster. It holds 5 to 10 times more mass than the entire outer Oort Cloud combined. We are talking about roughly 1 trillion individual objects larger than 1 kilometer wide. And just like the outer sphere, the Hills Cloud has never been directly detected. Not once in 44 years. But it is the physical scale of this thing that should really make you dizzy. Let's trace the map from Earth outward. You pass Neptune at 30 units. You hit the edge of our magnetic shield, the Heliopause, at 120 units. And then, nothing. You hit a completely empty gap spanning nearly 1,900 units. No solar wind, no clouds, just a massive, terrifying dead zone. And then, at 2,000 units, the Hills Cloud begins. Think about what I just said. That giant magnetic bubble, the Heliosphere, the massive structure we spent the entire first half of this story talking about, the shield keeping us alive. Compared to the Hills Cloud, it is just a microscopic dot. It is absolutely nothing. Everything we have ever considered to be the solar system fits inside the inner Hills Cloud the same way a single house fits inside an entire country. And even though we can't see it, we know the Hills Cloud is armed and loaded. Over the last few years, astronomers have found bizarre, extreme dwarf planets out in the dark. Objects with names like Sedna, Biden, and the Goblin. They have highly warped orbits that no known planet can explain, and their paths swing way out into the deepest, darkest edges of the system, right where the Hills Cloud is supposed to begin. These strange little worlds are the fingerprints of something impossibly vast. The Hills Cloud isn't just empty space, it is a sprawling, invisible ocean of debris. It proves that the safe, warm, illuminated zone of the solar system where we live is nothing but a tiny, fragile anomaly. And surrounding us on all sides, stretching halfway to the next star, is an endless, invisible arsenal of ice, drifting in absolute silence, just waiting for gravity to pull the trigger. But the most terrifying clues to our isolation aren't the objects zooming past Earth. They are the ones lurking in the deep freeze. Tiny chunks of ice with names like Sedna, Biden, and the Goblin are the most terrifying fingerprints ever found in modern astronomy. It all started on November 14th, 2003, at the Palomar Observatory in California. An astronomer named Mike Brown and his team were scanning the deep, dark edges of the solar system when they spotted a faint dot moving against the background of stars. They named it Sedna. It was roughly 1,000 kilometers across, but its size wasn't the shock. It was its orbit. The math made absolutely no sense. To understand why, you have to understand a basic rule of gravity. Orbits don't just magically stretch out on their own. If an object is moving in a massively elongated oval-shaped path, it means something massive had to pull it into that shape. But Sedna's closest approach to the Sun, its perihelion, is 76 astronomical units away. That is way, way beyond the gravitational reach of Neptune. Neptune can't touch it. The known giant planets can't touch it. And yet, Sedna swings out into the freezing void to an insane distance of 937 units, taking over 11,000 years to complete a single lap. There is absolutely no known physical mechanism and no known planet in our solar system that could have created this orbit. Imagine watching a baseball change direction in midair when there is no wind and no one there to catch it. That is what Sedna is doing. For a few years, astronomers thought Sedna was just a bizarre, isolated freak of nature. But then, in 2012, another team found an object nicknamed Biden with a similarly impossible orbit. Then, in 2015, they found the Goblin, whose orbit reaches a mind-bending 2,000 units out into the dark. Suddenly, it wasn't just an isolated incident, it was a pattern. But the real chilling moment came when scientists mapped these orbits on a 3D model. These objects aren't just moving in weird, stretched-out loops. Their orbits are completely aligned. They're clustered together, tilting in the exact same direction, like a flock of birds flying in perfect, slanted formation. The probability of space rocks randomly clustering like this on their own is roughly 1 in 10,000. It doesn't happen by accident. Something massive, invisible, and incredibly powerful is sitting out there in the dark, actively shepherding these objects. It is carving and shaping the outer edges of our solar system. The question that has consumed a decade of frantic telescopic searching and sleepless nights for astrophysicists is simple. What exactly is it? In January 2016, two astrophysicists at Caltech, Konstantin Batygin and the same Mike Brown who found Sedna, published a paper proposing an answer that made headlines around the world. They claimed the invisible shepherd was a massive, undiscovered world, Planet 9. Based on their orbital mechanics, this thing isn't just a tiny rock. It is a super-Earth. It has a mass 5 to 10 times greater than our own planet, and it sits in the pitch blackness somewhere between 400 and 800 astronomical units away, taking up to 20,000 years to orbit the Sun. The math is incredibly solid. The statistical evidence is there. But despite a massive global manhunt by the smartest people on Earth, using the most powerful telescopes ever built, it has not been found. And because we haven't found a planet, the door has been left wide open for much darker theories. In 2020, physicists published an idea that sounds like pure science fiction, but mathematically works perfectly. They proposed that the gravitational ghost pulling on these icy rocks isn't a planet at all. It is a primordial black hole. This wouldn't be a black hole born from a dying star. This is a relic formed from the chaotic density fluctuations in the very first fraction of a second after the Big Bang. Imagine a black hole that weighs as much as 5 entire Earths, but has been physically crushed down to the size of a tennis ball. It sits out there in our cosmic backyard, completely invisible to every instrument we have. It emits zero light. It absorbs very little matter. It is a tiny, silent, supermassive phantom. Now, there is a third group of scientists who argue that both ideas are wrong. They suggest there is no planet, no black hole, and no ghost. They argue the clustering is just an observational artifact, meaning we only found these objects aligned that way because that just happened to be where our telescopes were pointing. So, here is where we stand. A giant unseen planet. A primordial black hole the size of a tennis ball. Or absolutely nothing at all. 3 radically different explanations for the exact same data. None have been proven. None have been ruled out. A decade of empty searches usually means the object simply isn't there. But looking into deep space is not that simple. The search volume out at 800 astronomical units is unimaginably vast. An object out there gets almost zero sunlight, meaning it is freezing cold and impossibly faint. It moves so slowly against the background stars that it barely registers on a camera. Absence of detection does not mean absence of existence. The massive object governing the outer edges of our home could literally be sitting in our sky right now, buried as a single, unrecognized pixel in a photograph we have already taken. And that is the true horror of this mystery. The threat isn't that this object will swoop in and destroy Earth. The real terrifying implication is what it says about us. We love to believe we have mapped our solar system. We teach our children that it is an orderly, well-understood neighborhood of 8 planets. But the truth is, a gravitational apex predator the size of 5 Earths could be orbiting our own sun right now, and we are simply too blind to see it. If we can miss something that massive in our own backyard, what else is hiding in the dark? Whatever is lurking out there in the dark, a giant planet, a primordial black hole, or a swarm of unseen gravity, it is dragging around objects that are not normal space debris. They are flawless, ancient time capsules. Out in the darkest reaches of the Oort Cloud and the Hills Cloud, the temperature hovers between 4 and 10 degrees above absolute zero. At those temperatures, the very laws of chemistry basically freeze to a halt. Ice does not melt. Molecules do not react. The rocks sitting out there are made of water ice, methane, ammonia, and carbon monoxide, perfectly locked in the exact chemical state they were in 4.6 billion years ago, when our solar system was just a swirling cloud of gas. This means that every time a comet gets knocked loose from that cloud and falls toward Earth, it is carrying a pristine, unaltered piece of our violent genesis. And violent is the exact right word for it, because that massive cloud of frozen time capsules wasn't placed there gently. It was born in an absolute catastrophe. The architecture of this icy shield was forged in a violent catastrophe roughly 4 billion years ago. According to our best supercomputer simulations, the famous NICE model, the giant planets in our solar system used to be much closer together. But eventually, Jupiter and Saturn fell into a fatal gravitational rhythm. They hit a resonance that acted like a massive cosmic pump, injecting chaotic energy into the system. It violently flung Uranus and Neptune outward and scattered billions of icy bodies in every direction like shrapnel from a bomb. The rocks that were thrown outward, but didn't have quite enough speed to escape the sun entirely, froze in place and became the Oort Cloud. But the rocks that were thrown inward, they became the late heavy bombardment. For millions of years, an unrelenting storm of city-sized comets and asteroids rained down on the inner planets. If you look at the moon today, those massive dark craters covering its face, like Mare Imbrium, are the scars from that exact bombing campaign. But here is the most haunting detail of all: the timing. The very first microscopic traces of life on Earth date back to roughly 3.8 billion years ago. That is the exact geological moment the late heavy bombardment finally stopped. Life didn't just casually evolve, It clawed its way into existence the absolute second the cosmic carpet bombing paused. Our giant outer cloud was born from a catastrophe, and we were born in its smoking aftermath. For decades, we safely assumed that all the billions of comets in the Oort Cloud were our own shrapnel, thrown out by our own planets. But the chemical data tells a much darker story. In 2010, an incredible computer simulation showed what the Sun looked like when it was born. Like most stars, it wasn't born alone. It formed in a dense, crowded stellar nursery alongside thousands of other stars. For millions of years, these infant stars orbited extremely close to one another. And as they did, their gravity played tug of war. They physically traded planets, rocks, and ice. The results of the simulation were staggering. Up to 90% of the comets in our outer Oort cloud were actually stolen from alien sibling stars that have long since drifted away. And we actually have physical proof of this crowded nursery. We have found ancient meteorites on Earth containing unique isotopes, like aluminum-26, that can only be produced by massive exploding supernovas. It proves our young sun lived right next door to massive stars that were violently detonating. Our outermost border is built from somebody else's material. We didn't construct the walls of our own solar system. We inherited them from a stellar family that dispersed billions of years ago. The Oort Cloud isn't a wall we built. It is a cosmic graveyard of stolen ice, collected from stars that died billions of years ago. A giant, invisible sphere of alien debris is waiting 50,000 astronomical units away. The only question that matters for our survival is, what pulls the trigger? You might think it is just the random gravity of passing stars, or that hidden Planet 9, but the real answer is much bigger. It is the galaxy itself. In the 1980s, astrophysicists realized that the sheer mass of the Milky Way's galactic disk, roughly 1 trillion times the mass of the Sun, creates a constant, inescapable tidal force on our solar system. The gravitational pull is mathematically tiny, almost absurdly small, and yet, over billions of years, it is the single most dominant force shaping our survival. The galactic tide is the primary mechanism injecting comets into the inner solar system. Almost every long-period comet you have ever seen blazing across the night sky was ultimately pushed here by the gravity of the Milky Way itself. It proves a terrifying reality called the open membrane hypothesis. We like to think of our solar system as an isolated, safe little island in the dark. It isn't. The boundary of our system is not a solid wall, it is a semi-permeable membrane. We are physically sewn into the Milky Way by invisible threads of gravity, and the galaxy is actively, constantly reaching its fingers in, pulling icy bombs out of the dark and dropping them into our backyard. While the slow, steady pull of the Milky Way sets the general tempo, passing stars can violently speed it up. And one of those encounters already happened. On average, an alien star passes within a few light years of our Sun every 100,000 years. But roughly 70,000 years ago, right around the time early humans and Neanderthals were wandering the Earth, we had a terrifyingly close call. Astronomers discovered a binary star system called Scholz's star. It's a dim red dwarf paired with a barely visible brown dwarf. And when scientists traced its trajectory back in time, they realized that 70,000 years ago, it didn't just pass by our solar system. It flew directly through the outer edge of the Oort cloud. This wasn't a near miss, it was a direct hit. As that alien star punched through our outer shield, its gravity destabilized millions of frozen comets, kicking them out of their stable orbits. But here is the detail that should make your blood run cold. Space is so unfathomably huge that those disrupted comets don't just fall to Earth overnight. They get kicked onto massive, elongated trajectories that take tens of thousands of years to complete. That means the catastrophe from Scholz's star already happened 70,000 years ago. But the gravitational shockwave of falling comets is still crawling toward us. An invisible, slow-motion avalanche of ice was triggered before the dawn of human civilization, and it is currently falling inward right now. It is just a matter of time before it reaches the inner solar system. Scholz's star is a ghost from our past, but the galaxy operates on a cold, mathematical schedule, and the next massive disruption is already on the calendar. Currently sitting about 19.6 light-years away is a red dwarf star known as Gliese 710. Thanks to the Gaia Space Telescope, the most incredibly precise astrometric instrument ever launched, we aren't just guessing where this star is going. We have mapped its exact trajectory. In exactly 1.29 million years, Gliese 710 is going to fly right through our solar system. And unlike Scholz's star, which just grazed the outer edge, Gliese 710 is going to be a direct, devastating hit. It will pass at a distance of about 10,900 astronomical units. That means it isn't just clipping the outer Oort cloud, it is plunging straight into the massive, densely packed inner Hills cloud. The math on what happens next is terrifyingly clear. When that star plows through the dense inner reservoir, the sheer gravitational chaos will multiply the number of comets falling into the inner solar system by a factor of 10 to 100. For 2 to 5 million years, Earth will be subjected to an unrelenting, elevated risk of cosmic bombardment. This is not a theoretical speculation. It is not a statistical guess. It is a mathematical certainty, calculated from hard data. An event that will completely reshape the comet environment of our solar system has a specific scheduled date. And this is the true, chilling realization. We aren't going to plunge into global anarchy today, because an event is a million years away. But it fundamentally destroys the illusion that we live in a safe, permanent home. We are sitting inside a cosmic shooting gallery, and we now have the exact receipt showing when the next barrage of bullets will be fired. Knowing what is out there, and knowing what is coming, you might think our priority would be to send instruments out to the edge to set up an early warning system. Well, we tried. Humanity has sent exactly 5 spacecraft toward the deep outer solar system, and all 5 are either dead or currently dying. Pioneer 10 launched in 1972. Its last faint signal faded into static in 2003. Pioneer 11 went completely silent in 1995. Then, we have the legendary Voyager 1 and Voyager 2. Launched in 1977, they are powered by decaying plutonium. Right now, Voyager 1 is about 167 astronomical units away, tearing through the dark at 17 kilometers per second, but its power is dropping by 4 watts every single year. NASA is slowly shutting down its heaters and instruments one by one, just to keep it alive. Sometime in the 2030s, the very last heater will fail. The probe will freeze, the transmitter will go cold, and it will be dead. New Horizons, the probe that gave us our first close-up of Pluto, will suffer the exact same freezing death in the 2040s. The sheer irony of these distances is mathematically cruel. Voyager 1 is currently at 167 units. The dense Hills cloud doesn't even begin until 2,000 units. Voyager won't reach that distance until the year 2310. The outer edge of the Oort cloud is 100,000 units away. Voyager won't arrive there for another 30,000 years. That means by the time humanity's greatest explorer finally reaches the largest structure in our solar system, it will have been dead for 29,000 years. It will cross the boundary as a blind, deaf, freezing piece of metal, completely unable to report back what it finds to a species that might not even exist anymore. The sheer scale of the void guarantees that we cannot build a perimeter. The 5 dead probes are a haunting monument to our isolation. So, if our probes die long before they reach the edge, and the sheer scale of the void guarantees we can't physically build a warning perimeter, there is only one option left. We have to open our eyes wider than ever before. Sitting on a mountain peak in Chile, at an elevation of over 2,600 meters, is the Vera C. Rubin Observatory, and it is armed with the single largest digital camera ever built for astronomy, a staggering 3.2 gigapixel monster. Starting right now, in the mid-2020s, this observatory is doing something unprecedented. It is conducting the legacy survey of space and time. Instead of just taking static photos of the sky, it will scan the entire visible sky every 3 nights, continuously, for 10 years. It is essentially turning the static universe into a high-definition movie. Every single object that moves, blinks, or changes brightness will be catalogued. For the dark outer edges of our solar system, this is the ultimate threshold. For the first time since the Hills cloud was proposed in 1981, we finally have an instrument sensitive enough that it could detect those distant, frozen objects directly. If there really is a hidden Planet 9, or a massive clustering of unseen comets pulling the strings in the dark, the Rubin Observatory has a realistic chance of finally catching them on camera. And we already know there are mysteries waiting to be found. Just recently, before its power began to fail, the New Horizons probe looked out into the deep Kuiper belt and detected an anomalously high background glow of ultraviolet light. A massive, glowing energy signature with absolutely no identified source. It sits in the data like a terrifying question mark at the edge of the known universe. Historically, every single time we have pointed a new instrument at the boundary of our solar system, it has completely broken our models. IBEX found a massive, impossible ribbon of energy. The Voyagers found a deformed, boiling shield. The Rubin Observatory is orders of magnitude more powerful than anything we have ever used. If the historical pattern holds true, it is going to show us something we never anticipated. And based on every precedent we have, whatever it finds is going to make our situation look a whole lot worse. While astronomers are gearing up to look outward with new telescopes, the shield protecting us is actively changing in real time, and it isn't waiting for us to figure it out. Because our heliosphere is not a static, frozen bubble, it breathes. The sun operates on an 11-year cycle. When the sun is at its maximum power, the solar wind intensifies. The bubble expands outward, and it blocks almost all the cosmic radiation. Think of it as a deep, powerful exhale. But during a solar minimum, the sun's wind weakens. The bubble physically contracts. The shield shrinks and drastically more radiation pours into the inner solar system. We track this breathing with metronomic precision using something called neutron monitors, instruments scattered across Earth's surface that count the secondary particles created when cosmic rays smash into our atmosphere. During the 2019 to 2020 solar minimum, those monitors recorded something chilling. The Oulu neutron monitor in Finland, which has been continuously running since 1964, registered an all-time, record-breaking peak. It was the highest cosmic ray flux ever measured inside the solar system during the entire era of instrumental observation. And it wasn't just a one-off fluke. If you look at the data over the last few decades, the trend across every single solar minimum has been creeping upward. Every time the sun inhales, the shield gets slightly weaker than the time before, letting slightly more radiation through. Scientists are still fiercely debating whether this is just temporary noise in the solar cycle or the beginning of a long-term, catastrophic weakening of our heliosphere. But the data is pointing in a direction that perfectly aligns with everything we have discovered so far. Our armor is degrading. And this degradation couldn't possibly be happening at a worse time. Because, as we discussed earlier, the solar system is running out of safe road. For roughly the last 150,000 years, humanity has enjoyed the ultimate cosmic luck. We have been cruising through the local interstellar cloud, a relatively warm, thin, and safe pocket of space. But we are rapidly approaching the far edge of this safe zone. Waiting just beyond that boundary sits the G cloud. It is denser, it has a completely different magnetic field, and it is going to exert massively more pressure on our solar bubble. Astrophysicists have spent decades modeling this exact transition zone, and the calculations are grim. When we cross that boundary, the increased external pressure will physically crush the heliosphere inward. The edge of our shield will be pushed dangerously close to the Earth, the protective buffer will shrink, and a flood of deep space radiation will reach the inner system. This transition zone is fundamentally different from the random radiation spikes of the past, because now we have the full chain of evidence. We saw the beryllium-10 trapped in the ice, proving past compressions. We saw the Svensmark mechanism, proving cosmic rays create massive, planet-freezing cloud cover. We saw the extinction correlations. We saw the alien supernova debris pulled from the bottom of the ocean. The G cloud is no longer just an abstract astrophysical concept on the horizon. It is the trigger. If it compresses our heliosphere the way models predict, every single theoretical consequence we have discussed instantly becomes a live-action survival scenario. When exactly does this crossing happen? We don't know. The terrifying truth is, it might already be underway. We are driving a planetary spaceship toward a wall of dense gas at 26 kilometers per second, completely blind. There are no brakes, no steering wheel, and we will only learn we have hit the wall by what happens to us afterward. If you want to know what actually happens when a planet's protective shields fail, you don't need to run a computer simulation. You just have to look next door. The proof is sitting right there in the night sky. 3.5 billion years ago, Mars was practically a twin of Earth. It had a thick, dense atmosphere, flowing rivers, liquid oceans, and potentially the perfect conditions for life. But then, deep inside the planet, its molten core began to cool. The internal dynamo died, and with it, Mars's magnetic field collapsed. Without its own magnetosphere, Mars lost its personal planetary armor. Suddenly, the raw, unmitigated fury of the solar wind began slamming directly into the Martian atmosphere. Over hundreds of millions of years, the solar wind literally sandblasted the planet. It knocked molecules of air away one by one in a process called sputtering. Ultraviolet radiation cracked the ocean's water molecules apart, and the hydrogen simply boiled away into the void. Today, Mars is a frozen, irradiated wasteland with an atmospheric pressure less than 1% of Earth's. Mars is the ultimate forensic crime scene. It shows us exactly what a planet looks like when its shield dies. Earth seems perfectly safe under the blanket of its own strong magnetic field. But that field isn't permanent. It routinely flips its poles. During the last major magnetic reversal, roughly 780,000 years ago, Earth's magnetic shield dropped to just 10 to 20% of its normal strength, and it stayed that way for thousands of years. Unsurprisingly, the deep ice cores show massive radiation spikes precisely during that time. But here is the nightmare scenario. What happens if Earth's magnetic field decides to flip at the exact same moment our outer heliosphere gets crushed by the G cloud? Geologists have found ancient radiation spikes in the ice that are mathematically way too large to be caused by just a magnetic flip. It means it has happened before. Both shields, the Earth's magnetosphere and the Sun's heliosphere, failed at the exact same time. The cosmic flux at the surface multiplied exponentially, and whatever was living on the surface took the full, unfiltered blast of the galaxy. But the shield doesn't just slowly weaken or gradually compress. Sometimes it gets violently punctured, and it happens on a schedule measured in millennia. If you look at the rings of ancient trees all over the world, different species across multiple continents, they all share an identical, terrifying scar. In the years 774 and 775 AD, there is a massive, incredibly sharp spike in a radioactive isotope called carbon-14. When scientists checked the ice cores at both the North and South Poles for those exact same years, they found a matching, massive spike in beryllium-10. Whatever hit the Earth in 774 AD was a monster. It was an event 10 to 20 times more powerful than the absolute largest solar flare ever recorded in modern human history. The leading hypothesis is a solar superflare. The sun basically detonating a massive magnetic bomb that blew a hole right through our defenses. The alternative theory is even scarier. A gamma ray burst from an unidentified dying star outside our system acting like a cosmic sniper rifle. And the worst part is, 774 AD was not a unique event. We have found similar massive chemical scars in 660 BC, 5410 BC, and 7176 BC. The spacing is irregular, but the frequency is consistent. Roughly one catastrophic event every few thousand years. The shield gets punctured, the atmosphere gets blasted with the radiation, and the trees on every continent quietly record the planetary trauma in their wood. In 1859, a relatively minor solar storm called the Carrington event hit Earth. It was strong enough to literally set telegraph wires on fire, but an event 10 to 20 times larger, aimed at a modern human civilization that completely relies on GPS, vulnerable satellites, fiber optics, and fragile server farms. We have never been tested by something like that. Nobody truly knows what happens when the grid melts globally in a matter of seconds. But we know the punctures happen regularly. The last one was 1,252 years ago. The next one isn't a question of if, it is only a question of when. But a sudden puncture in the shield is just a temporary wound. The far more terrifying truth is that, eventually, the entire heliosphere is going to die completely. This isn't a theory. It isn't a might or a maybe. It will die. And its death is not some distant philosophical abstraction. It is a brutal physical process with a timeline we can calculate down to the physics of a dying star. In approximately 5 billion years, our sun is going to exhaust the hydrogen fuel in its core. When that happens, the core will collapse, and the star will begin fusing hydrogen in an outer shell. The sun will swell into a monstrous red giant, expanding so enormously that its fiery surface will swallow the orbits of Mercury, Venus, and likely Earth itself. During this apocalyptic phase, the solar wind will intensify by a factor of roughly 10,000. For a brief, geological moment, that supercharged wind will push the interstellar medium incredibly far back. The heliosphere will expand to hundreds of astronomical units. As the Earth burns, our solar system will ironically have the largest, strongest shield it has ever had, but it won't last. Soon after, the sun will completely shed its outer layers, blowing them away to form a massive, glowing planetary nebula. All that will be left in the center is a white dwarf. It will be incredibly dense and hot, but tiny, roughly the size of the Earth, containing only half the sun's current mass. And here is the fatal catch. A white dwarf produces almost zero stellar wind. Without that wind, there is no outward pressure. Without outward pressure, there is no heliosphere. The giant protective magnetic bubble will simply collapse. The cold, highly radioactive interstellar medium will rush inward, flooding the vacuum where our massive shield used to be. Whatever remains of our planetary system, the burnt cinders of the planets, the frozen rocks of the outer dark, will sit completely naked in the galaxy, stripped of any magnetic defense whatsoever. The heliosphere is mortal. It had a birthday roughly 4.6 billion years ago, and it has an absolute expiration date written into the fuel gauge of the sun. The structure that makes every single living thing on this planet possible is strictly temporary on the timescale of the universe. It will end. The only question that matters for us is whether the current, incredibly rare balance of pressures that creates our specific safety zone will persist for even a fraction of the time we have left. And as we have seen, everything buried in the ice, in the mud, and in the data says those conditions are far less stable and far less permanent than we ever dared to assume. In 2025, NASA is launching a brand new mission called IMAP, the Interstellar Mapping and Acceleration Probe. If you read the agency's official documentation, the justification for the multi-million-dollar mission is stated incredibly bluntly. The data we got from the IBEX satellite and the Voyager probes is simply insufficient for understanding the heliosphere. Let that sink in. This isn't a minor refinement mission. It is a stunning admission of defeat. The exact same space agency that built the original instruments, received the data, and published the textbooks is publicly admitting that the data makes absolutely no sense. The models are broken. They are literally starting over. That same year, the massive Vera Rubin Observatory in Chile will begin its 10-year scan of the night sky. For the first time in human history, we will have an instrument sensitive enough to directly detect the trillions of frozen objects hiding in the massive Hills cloud. We are finally going to test the theories of Planet 9, primordial black holes, and invisible gravitational ghosts against the largest dataset ever assembled. We are going to find out exactly what is pulling the strings in the dark. But amidst all this new technology, here is the one thing that will not happen. No new spacecraft is going to reach the edge of the solar system. Within the next decade, Voyager 1 and Voyager 2 will finally succumb to the freezing cold. Their nuclear batteries will fail. Their transmitters will fall utterly silent on a schedule we can calculate almost to the year. And the moment that happens, humanity will not have a single operating instrument beyond the orbit of Neptune. Not one. Everything we learn about the true boundary of our solar system from that point forward will have to be guessed from the inside. We will be trapped on Earth, looking through telescopes, studying remote data, and essentially staring at shadows cast on a wall, trying to deduce the shape of the monster casting them. Even if we started building a brand new, modern probe today to replace the Voyagers, the sheer physics of distance means it wouldn't reach the edge until the middle of the 22nd century, at the absolute earliest. We are about to lose our only direct, physical contact with the edge of our home. The two brave little spacecraft that taught us everything we know about the boundary, and more importantly, taught us that everything we thought we knew before them was completely wrong, are running out of time. Soon, they will go dark. And then, humanity will be completely alone with our broken models again. We will be flying blind into an ever-changing hostile galaxy, hoping the shield holds, while knowing deep down that the universe makes no promises.